Hi everyone, my name is Raksha Khan and this is my Physics 2 Lab 1 on the amount of excess charge on an ordinary object. So the goal of this lab is to determine how much excess charge, which is the amount of excess or deficient electrons, is transferred to a piece of charge-clear tape after contact. And the purpose of doing this lab is so that we can visualize and observe the transfer of electrons in everyday objects to help give us a better understanding of how charges react. For this lab, we'll be applying Coulomb's law, which includes an understanding of electric field, electric force, point charges, and lastly, gravitational law. And you can see all their formulas here on the side. Here is a summary of results of the most important parts of the lab, which is finding the magnitude of gravitational force, which is equal to the magnitude of electrical force, the distance, number of electrons, atoms, and then the ratio of electrons to atoms. So some expectations of how the U-tapes behave before beginning the lab. I expected that if the tape is positively charged, then it'll be attracted to the pen. If it's negatively charged, I expect it to repel the pen. And if it's neutral, I still expect it to be attracted to the pen. Some observations. I observed the tape getting attracted to my hand. It was also attracted to a book, which is a neutral object. After rubbing a clear plastic pen or on cloth, I observed the pen and tape attracting each other, and since the pen is negatively charged, we can conclude that the tape is positively charged since we know that opposite charges attract. So answering some questions, we can conclude that the net Y component of tape B is 0, and the gravitational force from the Earth and the force from tape A are the forces acting on the tape. And since gravitational force equals to mass times g, we need to measure the mass. So some measurements and calculations that I got. The length of the tape was 20 centimeters, and since we know the density of the tape, based on our length, we can calculate the mass since density equals mass divided by volume. And so we get the mass of the tape to be 0.2 grams. The distance between the two tapes when one of the tapes began to flow above the other was 16 centimeters. And so we can calculate the magnitude of the gravitational force on the tape to be mass into g, which it gives as a result of this. And then the magnitude of the electric force is the same, equal to the magnitude of gravitational force, so we obtain the same result of that for that as well. So some further calculations, since we know that the gravitational force is equal to electric force, we can equate the two formulas, and then substituting the distance between the two tapes and the gravitational force, as well as a constant k to solve the charge for B, we get this. And the number of deficient electrons can also be found out using the formula. The number of atoms on the surface of the tape can also be found out. And then finally, using these two results, we can find the ratio of the number of electrons to the number of atoms. So here is the coding. Here is the link to my computational coding for this lab. I attached a screenshot of it here as well. And this is the output results once you run this program, and you can see the results I obtained computationally, and you can also kind of figure out what assumptions I made looking at my code. So answering some final questions. If electrons had positive charges and protons had negative charges, then we'd still not really see any major changes. The tapes would still propel and float. Only the signs would be switched, but we still get the same overall observation. And in terms of why it's important to handle the charged tapes as little as possible, when coming into contact with our hands or other objects, the tape's charges can transfer, and that would make the tapes neutral again, which is obviously not what we want for our experiment. So in conclusion, our goal was to determine how much excess charge was transferred to the piece of tape after contact. And through this lab, we determined that to be equal to this charge number of electrons. To obtain the value, we applied a variety of different fundamental physics principles, which we talked about. And so doing this lab kind of did do the purpose of allowing me to visualize and observe the transfer of electrons, and it gave me a better understanding of how charges react. And even when we computed this lab in, assuming ideal conditions, for example, not assuming that there's no air resistance, we still got a similar value for the charge, which kind of validates my experimental lab results. And that's it. Thank